Very good day to all the fellow viewers. We are master students in project management from University Science Malaysia, and we are honored to present to you our training program entitled Integrating Internet of Things in Construction Site Safety Management. First of all, we already know that safety always comes first, and it should be a priority in every workplace. So my next question is, why is the site safety so important at the construction site? The answer is very simple. Construction is one of the professions with most dangers and hazards, and accidents happen sometimes. So site safety management is to ensure a safer working environment for the workers at the construction site. Do you ever heard about the recent construction accidents happened in Suk Highway, Malaysia, which shocked the whole construction industry? There were 2 accidents happened in the same project in only 6 months' time, and 3 foreign workers were killed at the scene in March 2021 incident. Now let us have a look on the statistics on occupational accidents in the construction industry. We can summarize that although there is a slight decrease of death incidents reported from year 2015 to 2018, however, death incidents increased dramatically during 2019. The cases reported for non-permanent disability increased from year 2015 to 2018, but decreased starting from year 2019 to 2020. These are the 5 most common construction accidents in general, sources taken from DOSH report. Firstly, falling from heights. Secondly, struck by falling objects. Thirdly, struck by moving objects or vehicles. Next, caught in between. And lastly, fall into opening or drowning. Here we look at the other 4 common accidents happen in construction sites, which are namely electrocution, environmental factors, fire, explosion, and exposure to or contact with harmful substances. So here comes my question. Despite the effort of implementing rules and regulations on site safety according to international standards and guidelines, the number of accidents seems does not reduce significantly. So, what actually are the main causes of the construction accidents? Firstly, workers' negligence. Workers who act carelessly and failure to carry out site works, such as operating machines without observing the working surroundings, may lead to workers being struck by moving objects or vehicles. Workers' failure in taking care of the equipment and tools may lead to workers being struck by falling tools from higher platforms. Therefore, being cautious and responsible is important in construction sites to ensure other workers are not harmed. Secondly, is the failure of workers to obey work procedures, especially the standard operating procedures when handling machines or entering the construction site. Accidents can be avoided if every worker obey to the SOP stated. Next, working at high elevation is one of the main causes of accidents in Malaysia. Working at higher platforms such as high-rise, highway bridges, slope construction has higher possibility of accidents, and any mistake could cause falling from high elevation. Most fatal accidents happen due to this factor. It is compulsory in the guidelines that workers working at higher elevation requires personal protective equipment to ensure their safety, such as safety belts and harness safety line. Poor site management is another factor of accidents happening in Malaysia. Project team including project manager, site supervisors, and safety officers play important roles in managing site safety all the time and ensuring all safety protocols have been carried out. Safety briefing is compulsory at site to ensure all the workers are well briefed and reminded on the safety procedures for each activity at site. The poor management will result in accidents when workers are not being reminded to wear safety equipment when carrying out site activities. Therefore, workers might easily get struck by falling objects or even moving vehicles. The next cause of construction accidents is the lack of knowledge and skill levels of workers at site. This may result in accidents, especially in operating complicated machines which requires higher skill level or handling toxic or flammable substances. Training courses to the workers or hiring specialized and experienced workers may help to ensure that accidents won't be happening due to knowledge and skill level. Next, failure in wearing personal protective equipment may lead to accidents mostly struck by falling objects or falling from higher elevation. As mentioned earlier, personal protective equipment is extremely important at construction sites, which could probably save someone's life. Most common wearable personal protective equipment are safety helmets, safety boots, safety gloves, safety goggles, safety belts, and etc. The last cause of accidents I would like to mention is the poor workers' attitude about safety. Some workers may have bad attitude and does not even take safety seriously at site. Asking them to obey the safety procedures and rules seems to be a tough decision for them. That's why this kind of site personnel, they do aware of the site safety knowledge and protocol, but they are just lazy or do not want to follow due to their own ignorance. Site safety management is important at site to avoid unnecessary accidents from happening. Therefore, safety management system, which is a systematic way of identifying hazards and managing risks relating to construction workplace, should be introduced at every construction site to ensure the safety of the workers and to protect the stakeholders as well.
Now, we will talk about the key processes of site safety management. The first key process of site safety management is the establishment of policy and commitment. Safety policy is a recognized written statement of an organization's commitment to protect the health and safety of the employees as well as the surrounding communities. The safety policy overlays the measures taken to protect the employees. There is a need for the project and site team to propose and establish an occupational safety and health policy program as a requirement under Section 20 of the Safety, Health and Welfare at Work Act 2005. The policy shall always prioritize the safety of the workers in all works at site. Commitment from all members of the organizations and team in regards to safety and health prioritization, as well as compliance to safety codes, shall be guaranteed 100%. Safety policy shall minimally be formed with the following 3 sections, including: Number 1. Statement of the policy stating the employer's commitment to manage health and safety and stating the goal of the policy. Number 2. Responsibility, which is the appointment of a responsible manager and his team to implement, enact, and track the implementation of each element of the safety policy. And number 3, outlines of detailed procedures or standard operating procedures (SOP) of all forms of works where hazards are involved. As there are many safety policy and procedure modules involved, some of the key ones may include confined space policy and confined space entry procedures, crane safety policy and crane safety procedures, electrical safety policy, emergency access and exit, excavation and trenching, fall protection policy and procedures, ladder safety policy and procedures, scaffold safety management and procedures, waste management policy and procedures, chemical and hazards management, and etc. The second key process of site safety management is planning. While the safety policy and SOP in key step 1 may be standard across several projects in the organization, a detailed plan formulation is required to fulfill the safety policies. Some of the key information that needs to be sorted out during the planning stage of the site safety management process may include, but not limited to, the following: A. The nature of the project and its risk levels. B. The available site topography drawings and structural information. C. A soil test result. D. The safety and health hazards identification and management. E. Site-wide factors such as the nearby schools, terrains, railway or infrastructure, etc. A pre-tender stage safety planning is necessary to ensure the contractors are fully aware of the health and safety requirements and cost in all the necessary. The information of the planning shall mainly be derived from the client, who owns a specific description of the site hazards or surveys, or the designers or engineers who assessed the risk of the site during their design and needs to cascade the necessary information to the main and subcontractors. An effective management structure shall be in place for the deliverables of such policies. The planning stage shall also consider the investment in technologies for effective site safety management, such as real-time monitoring sensors and controllers on site. Subsequently, the third key process of site safety management is implementation and operation. The aforementioned site safety policy and planning are not just a show of involvement without a proper implementation. The organization involved needs to develop full capability to achieve all the policies, objectives, and planning that is laid out. Motivation of all site workers shall be done on a regular basis with safety toolbox meetings and the celebration of accumulated safe man-hours at site. This motivation shall encourage the prioritization of long-term health and not just merely to avoid accidents. The provision of personal protective equipment (PPE) suited for all types of site conditions shall always be applicable. All actions deemed inclusive in the planning stage, as well as all known safety regulations, has to be carried out to minimize and eliminate risk, and no omissions of such is allowed to save cost at the expense of safety and health. The assigned safety officers and his team must be properly empowered to enforce site safety compliance at all times. Last but not least, the final key process of site safety management is measuring and auditing of performances. In other words, measurement, monitoring, and evaluation of site safety and health performances. The safety performance shall be measured to review when and where safety standards needs an improvement. This process is when the use of technologies may prove to come in handy. Active self-monitoring system with sensors shall replace human inspections, which may not be as comprehensive and error-free as the technology may do. Sensors coupled with image processing neural networks can collect data of safety compliances and feed to a controller to analyze safety compliances at all times. More details about site safety monitoring with the aid of technologies will be presented in the subsequent sections of this video. In the near future, heavy equipment shall minimally be equipped with central monitoring to ensure that the operators are using them correctly. Otherwise, an alarm may be triggered to notify the misuse to the operators. The master controller may even generate a safety scoring for the project team in terms of safety and health compliance. Afterward, a systematic review of the analysis based on the collected data and independent auditing needs to be run regularly. Next, post-analysis actions include complement in various forms offered for excellent records of site safety compliances, and on the other hand, disciplinary actions against any misdeeds shall be fairly administered to ensure all workers participate in full commitment. Should an accident happen, immediate investigation to the cause and effect of the accident needs to be generated and cascaded across the project team. Preventive and corrective actions needs to be undertaken immediately. The Section 80 of the 2005 Act on Liability of Directors and Officers of Undertakings necessitates the organization to be in position to proactively manage safety and health of their workers.
Now, let me bring you to see how IoT integration can produce a safer construction site. It overcomes loopholes in safety monitoring, having real-time insights on employees and machineries, and also managed with greater precision and minimal human involvement. First IoT devices I'm going to bring to you is Radio Frequency Identification, RFID. RFID tag is fixed to workers' personal protective equipment like uniform, helmet, vest, or shoes, along with smart sensors. When workers wearing the RFID sensor tag inside, they manage to provide on-site safety data by capturing the image on-site. RFID readers are placed in strategic checkpoints to read the safety tracking information detected from sensor tags. Next IoT devices is Global Positioning System, GPS. This technology gathers and analyzes location-based data on equipment and workers to achieve real-time positioning. The third IoT device is drones. It is an unmanned aerial vehicle that can be piloted remotely using a smartphone, tablet device, or a computer. Since the drone is equipped with video cameras, it can provide the construction teams with an overhead view of site, materials, machinery, and people by images or real-time videos around the construction site. For IoT systems, there are 4 major stages of implementation. First and foremost, data collection process. IoT in construction involves the use of smart sensors which are placed around job sites or worn by workers. IoT devices for construction are able to collect certain kinds of data about activity, performance, and conditions on the construction site. Data transmission is the stage which comes next after data collection. Collected data by IoT nodes is transferred to a gateway server which will then aggregate and send it to a cloud platform for further data processing. The next stage is data analytics. This is when management collect, process, and analyze the incoming data on site with cloud computing for real-time analytics and actions. This stage is useful in preventing workplace injury after corrective measures are put in place. The very last stage is data storage. After analysis, all data is stored in cloud database for future use, like identifying potential construction risks in design and construction phase. Now, I'm going to talk about the application of IoT in construction site. First, risk assessment and accident detection. As IoT can effectively recognizing the hazards, assessing the associated risks, and then bringing the risk to a tolerable level. On the construction site, IoT devices track both worker and environmental data. This data is sent to computer system for data processing. Hence, management can monitor the site with real-time data feedback on location. With the live analysis of data, the threat to employee safety can be foreseen before accident happen. So, the management is able to react quickly to the potential risk. Also, the problem can be identified quickly by alert system and remind the user on danger. Second, real-time tracking on site and workers. Let us look from attendance management and reporting component. Currently, site safety management systems are mostly manual, spreadsheet-based, and sometimes inefficient. It will track the workforce only at the entry and exit. To address this problem, we have 2 solutions: RFID or GPS-based tracking. IoT enables you to have an efficient and technology-based real-time tracking and management on your workforce. Without IoT, workers can be easily escape from site and go to somewhere else without being noticed by supervisor. However, with IoT, supervisor can keep tracking their attendance as the readers will always be tracking on them. Any mischief or wrongdoings will be immediately noticed. Besides tracking on workers, IoT can be used to track equipment and assets on site. IoT technology make equipment and machineries on site to be location aware. It can send information about its location and how it is being used to other computer systems or human staff in real time. Third, real-time visibility. For example, the usage of drones provide real-time information and enhance the dataset through photographic visualizations. This can ease the professionals across different departments to visually survey buildings in areas that are difficult to reach or pose a health and safety risk for humans to enter. Also, it can lead to significant improvement in surveying accuracy. Fourth, BIM and IoT integration. IoT system is just containing a list of sensors and sensors values. we need to have some context to understand where the sensor is located and what is the significance of this value. The beam model is a natural way to give meaning and context to this sensor's value and to also relate the values to each other. When these data are integrated, it provides a lot of value in analysis and diagnosis of problems. One way to look at BEAM is to look at it as an aggregation platform. Typically, in most construction projects, designers are using BEAM. That means data is already there in a structured format, and it would make sense to combine that data with the additional data that's going to be added to the building. With these data, it provides a more effective safety control of project during modeling, visualization, and simulation. That is to say, the safety control of project can be more efficient with the real-time information sharing by IoT system and a statistical analysis of common problems according to information gathered from database. Last, data visualization in augmented reality, AR. Data visualization methods allow users to have a view of real-site environment and also aid in identifying any safety problems that may be or are currently faced by an employee. IoT devices capture data from the physical construction site so that it can be analyzed, and AR devices take that digital data and render it back on the physical world for people to view and interact with.
How Internet of Things changing construction site safety management. First of all, we can look at the comparison of on-site management in terms of traditional practice and post-Internet of Things implementation. In the past, management had problems in terms of lack of accurate information data regarding to the safety management, but now no longer because Internet of Things had help in terms of real-time safety risk assessment. Besides, Internet of Things had improvised in terms of information delivered and storage that before the management had issue in late data collection. Late data collection has resulted in delay and limitation in determining a decision where it will be impact the safety of management and employees. Therefore, risk evaluation and accident prediction will help a company eradicate this issue. Traditional practice in construction site safety had adopted not to share information related to the site safety to the agency and companies involved in order to conceal unforeseen accident while maintaining the good name of the company. But this behavior will gamble the welfare of the employees on site and can be categorized as poor management. Therefore, with Internet of Things implementation will help to improve safety management. Internet of Things implementation improved in three concepts. The Internet of Things paradigm is the product of the fusion of three concepts. Firstly, things-oriented version. Secondly, internet-oriented vision. And the thirdly is semantic-oriented vision. The things-oriented vision example how to incorporate generic object within a shared context. Internet of Things can thus be seen as a mechanism for autonomous data collection, event conversion, network connectivity, and interoperability. The Internet-oriented vision guides a network-oriented concept, which allows for the connection of a vast number of communication devices. Finally, because of the enormous large number of objects involved in the future Internet, semantic-based vision plays a critical role in overcoming the issue of coping with the massive amount of knowledge provided by Internet of Things. Major advantage of Internet of Things you must know. In this regard, the Internet of Things technologies can be utilized in order to optimize the systematic process of business. The new generation of Internet of Things based situation-aware computing application were found to be beneficial to solve communication problem in dynamic site condition. Consequently, it was revealed that the purpose design has a potential to reduce the risk of construction site accident with a low capital and operational cost. Therefore, a framework was provided to decrease the time for decision making and thus to have a better project management performance in construction industry. Advantage of Internet of Things in modeling. The result of implementation of Internet of Things in modeling platform has some significant contribution. Introduce a multi-dimensional Internet of Things help to achieve real-time visibility and traceability in the prefabricated construction. Besides, smart construction objects which can collaborate with Internet of Things to ease operational were presented. A multi-dimensional BIM platform was created in order to provide opportunities to stakeholders to share information. Lastly, through the purpose platform, a better monitoring process was provided for the end user. Last but not least, advantage in terms of construction are safety management will get a notification of possible hazard toward the site employees in real time. Hence, it will help the management to reduce the site construction accident. Secondly, it will be index of possible risks for review and general site safety progress. The simplest incorporation of disparate sensor in Internet of Things middleware. Lastly, Internet of Things also had an advantage by low cost dependable implementation, low power energy harvesting scheme.